All right, the final question we have to talk about here is the domain. This second part of the question. What's the domain of the composition? So, what did we have? We have F composite G of X, and we have that is equal to F or 4X minus 13 over 4 4x minus 12. That's the composition, and we want to know the domain of the composition, the domain of the composite function. What does domain, so there's another video on domain, but just to review, the domain is what values of x are permitted in a function. What inputs are allowed. There are really only 3 limitations that a precalculus student, algebra student, will find if they're talking about domain. The limitations are the denominator. The denominator cannot be 0. The radicand of a even root. Now we're usually talking about square root, so the radicand of a square root must be greater than or equal to 0. And then there's the final one, which you may not encounter at all, or maybe you have encountered it, but it's context. So that's if we're dealing with a word problem, and say we're talking about money, and it doesn't make sense to have any negative money, so the domain is greater than 0. So these are the only 3 times that we're going to have a limitation on the domain of a function. And of course, if you're reading closely here, you're seeing that the denominator cannot be 0 is the one that's going to come into play here. So we're going to just say that I want to find out when does the denominator equal 0. And you can look at this easily enough and tell, right? But if I needed to, I could say, all right, when does that? I'm going to set the denominator equal to 0, and I'm going to solve for x, add 12 to both sides, divide by 4, and I get x equals 3. So that is when it will equal 0. But I don't want it to equal 0, so I'm going to eliminate 3 from the domain. And then we have this issue of writing the domain with these interval notations here. So these little choices here are what are setting us up to say interval notation. So instead of saying that the domain is x is greater than 3, which is what actually, that's not what I want to say. Not greater than 3. I want to say x does not equal 3. So instead of saying the domain is x does not equal 3, and then maybe I would add in there, it's all real numbers except x does not equal 3. So instead of saying that, we use this interval notation where we're going to say we're going to go for values of x from negative infinity up to 3, but not including 3. So if we use parentheses, that means not included. Or if we use parentheses, that's going to be with infinity. So infinity is always going to be used with parentheses. And then I'm going to go union 3 up to infinity. So that's just kind of an inconvenient way of saying everything except 3. That's what that notation means. It's called interval notation. Interval. All right? Okay, so I need to look at another case here that brings up a difficulty, a little bit of a challenge here. Like if I have, say, and I have a f of x is equal to x squared minus 3, and I have g of x is equal to the square root of x minus 5. And then I go the composition, f composite g of x, which is f of g of x, which is f of the square root of x minus 5. And then I plug the square root of x minus 5 into the function f. So that's x minus 5 gets squared, and then I subtract 3, which gives me x minus 5 minus 3 equals x minus 8. All right, so you need to be able to follow all that, find the composition of this different pair of functions here, and then we're asked for the domain. Now, what did I say? I said the domain only has 3 types of limitations: denominator, the radicand, or by context. All right, well, we don't have a denominator here. We don't have a denominator here. We don't have a radical, and we don't have a context. So normally, we're going to say, oh, the domain is all real numbers. And in that case, if it were all real numbers, the way that we say that with interval notation is negative infinity to infinity. But that's not what we do with a, with a composite function. We have to think about the whole picture of where this x minus 8 came from. That I started with g, and then I went into f, and then I came out with the composition. And I have to think about that flow of inputs and outputs, and is there any limitation in there on the domain? Now with this one, we get lucky. We don't have to think about it. We can just go straight to the denominator and just say that's our limitation. We could go through the process that I'm about to go through, but it's not necessary in that case with that particular problem. With this one, I have to say, all right, g is coming from this. So remember how this is calculated, or how this works. We go f of g of x. So we're starting with g of x, and we're getting that result, and then we're going to f. So that this g of x has a limitation, I have to use that limitation on my domain. So in this case, I'm actually going to say that x minus 5 has to be greater than or equal to 0 for the composition, even though, again, the composition is x minus 8. But I started with the square root of x minus 5, and that's where my limitation is. So I need x minus 5 to be greater than or equal to 0, and that's going to be x is greater than or equal to 5, and then I'm going to take 5. Now here, 5 is included, so it gets a bracket. Remember back here, 3 was not included. I wanted to not include 3, so it got parentheses. So here the 5 is included, and then everything greater than that, so I'm going to go comma up to infinity. And there's no union here, like in this previous one. There was a union right there. There's no union in this one because I only have the one part. I just have the one part here, 5 to infinity. All right, one more about the limitation on the domain, and that is if I end up with a composition, so say I end up with an F composite G, and say it ends up with like x is equal to x plus 1 over the square root of x minus 3. All right, now I have two things going on here. One is I need x minus 3 to be greater than or equal to 0 because I've got a radicand that is placing a limitation on my domain. But the other thing is that I have this denominator as well. So if I just took into account the radical, then I would be saying x is greater than or equal to 3. But I can't have x be equal to 3, because if I have x equal to 3, then I'm going to have 3 minus 3 is 0, and I'm going to have a 0 in the denominator. So in addition to using the radicand to limit myself to x is greater than or equal to 3, I also have to eliminate the 3 from here. So I'm actually going to say x is greater than 3, and my solution is going to be 3 to infinity. And that's going to be a pretty common problem that people are going to maybe use a bracket here when they should use parentheses, because I don't want to include the 3, because the 3 would make this come out to 0. And that is the domain of a composite function.